This product is what we call the Cummins HSK78G genset. It's a product, an engine that was designed from the bottom up, so it's a brand new natural gas genset. It's not a genset that's based on a different engine, it's not a gasified engine, it's completely brand new. The other thing too, it's one that we designed to be the industry's leading robust, reliable, as well as efficiency in regards to high electrical efficiency. So we designed the genset to be the industry's most reliable, flexible, and robust genset while maintaining that high electrical efficiency. So for 50 Hertz, we're expecting an efficiency of 44.2%, and for 60 Hertz, an electrical efficiency of 43.5%. So in regards for the engine, we have a much higher power density. Our current gensets are able to produce 2 megawatts. It's a 91-liter engine, a QSE 91. Whereas now with the HSK78G, we have the higher power density because the 78 liters is able to produce 2 megawatts of power. That's due to the optimization and design of the bore and stroke, a completely different engine design. Again, it's from the ground up. We have fuel flexibility, so we can accept a wide range of fuels, all the way from our standard pipeline natural gas, low BTU fuel, such as landfill, biogas, gases from wastewater treatment plants, even flare gases, gases that go all the way down to about 40 methane number. So most of the power output is going to be at 2 megawatts. That's going to be our highest rating of the machine. And we won't derate until we get to about a 70 methane number fuel, which is a great achievement. Obviously, as we go down in methane number on the fuel, then we have to derate a little bit. At a 40 methane number, which is typically flare gas, the power output will be 1,600 kilowatts. The other portion is the fact that we have a built-in methane sensor and NOx sensor. The NOx sensor is helping us to ensure we meet the desired emissions of the engine, and it helps us keep that standard all the time. So that way, it's less time that a service engineer would have to come back and readjust the engine. So that's why we call it a self-calibrating, self-adjusting engine. Especially with the methane sensor, that helps us having that wider flexibility on gas acceptability and even fuel variation. It's definitely been about 4 years or so. It's taken a lot of work. It's taken a lot of dedication. A lot of engineers, a lot of man hours have gone into this. We've done very careful designs. We produce, we have our VPI program, and we go through very rigorous steps to make sure that everything gets designed up to spec, up to Cummins standards. So every design review that we go through, and for this product is something that we've designed to be a global product, because we made sure to be a CE certified, UL certified, as well as CSA. So that way it can go to a lot of regions throughout the world. The other portion too is that we've designed it with service in mind. So we always have service during the design reviews to make sure that they are approved of the design, the placement of the components, and even the major overall design as well too. So we've changed the air filters to go from the rear. We've put them up the way to the front at a much lower profile. So that way it helps us remove them. It helps us for shipping purposes as well. So even a 6-foot person can remove them without even having to go into a ladder. Other portions as well too, we have a lot of onboarding diagnostics. So a lot of sensors within the system that helps us monitor how's the engine doing, as well as do predictability on of any potential failures. The other big thing too, where we've done a lot of improvement, especially on service time, is that we've implemented a split core design on the coupling between the engine and the alternator. So now you can just remove the top of the coupling, so to the split, and be able to service the coupling without having to roll back the alternator. In the event that you need to remove the alternator for some reason, then we do have a rollback tool, so that way you can just roll it without having to lift the whole alternator. So some of those improvements have helped us decrease the amount of service hours, going from about 20 hours down to 2 hours by just implementing the split core design. Another huge improvement is our service intervals, which our minimum service interval is going to be 2,000 hours. Our midlife of the engine is going to be 40,000 hours, and our major overhaul will be 80,000 hours. So it's something that we've improved from current product that was 60,000 now to 80,000. Then in regards to fuel flexibility as well, it's not just the different fuels that we can accept, but also the contaminant levels. So we can go from a very clean fuel to a very aggressive fuel. So that contains H2S, siloxane, silica, ammonia, etc. that the engine's able to handle without having to then implement a pre-treatment installation to clean up the gas. So now it's just one less capital expense that a customer has to do to implement the genset. So as I mentioned already, the big one is the service intervals. So they're much longer. So again, that's going to help us a lot, saving operational expenses, which when you combine the savings on operational expenses with the savings on fuel due to the high electrical efficiency, that's going to help us lower our total cost of ownership, which is key for most of our customers because that's what they want to see. They want to look at not just the capital expense, but also the CapEx and the OpEx. We're going to have 3 power ratings, so it's a 1600 kilowatt, an 1800 kilowatt, and then a 2000 kilowatt or 2 megawatt. Both 50 and 60 hertz, regardless of which of the two frequencies. Our generator controller, we're going to have a 15-inch HMI colored touchscreen, so that way you can do a lot of monitoring within the system. It's going to look just like our DMC screen. So if you're familiar with our switchgear components, such as our digital master controller, you're able to just pretty much transfer from one to the other very seamlessly. So it's not really something new. It's not really a new interface that you have to learn, because it's something that you're going to be very familiar with. Other aspects is the fact that you have, in regards to onboarding diagnostics, you can monitor a lot of those different parameters within the genset controller, as well as even having live trending in the controller itself. So you can just go up to your screen, select up to 8 parameters at a time, and then you can monitor how they're all doing at once. Other aspects of service is the fact that we can monitor from each cylinder the exhaust temperature, the NOx events, so NOx count, so we have NOx sensors in each individual cylinder, as well as then the spark plug voltage at each of one of them. So it helps us more on that, determining any potential failures. So that way we can monitor what's the spark plug like. Do we have any issues in each of the cylinders? So it's more of that onboarded diagnostics.